right, so last class we talked about protons, neutrons, electrons. We talked about atomic number, atomic mass, how to calculate the neutrons with specific data given to you, how to calculate protons, all of those. Today we're going to talk about isotopes, and we're going to talk about electrons and what happens to them in their rings, okay? So whenever you have two or more forms of the same element, that is called an isotope. They contain equal number of, and you can answer this question based on the diagram. What do they have equal numbers of? Protons and what? Okay. But they differ in their neutrons. Look, if they differ in their neutrons, they have to differ in the atomic mass, because the atomic mass is calculated by adding what? And the neutrons. If you add the protons and the neutrons, you get the atomic mass. So if the neutrons differ, the atomic mass differs. That's what an isotope is. So this is an example of carbon. And you have carbon 12, carbon 13, carbon 14. They're different forms of carbon, and they are called isotopes. That is all you need to know about an isotope for this test. The understanding of it and all of that is going to come later on, but basically, it's almost like a vocabulary word. If you see any atoms, configuration, and we call this their configuration, and the electrons are the same, but you see something different about the atom, you know it's an isotope, okay? So, let's focus on the electrons now. We know electrons float around outside of the nucleus. They're part of the atom. Just because they're floating around doesn't mean they're not part of the atom. The atom has inside the nucleus protons and neutrons, and floating around are the electrons. The electrons should always have a maximum number in each shell. So if you are shell number 1, how many electrons should be there? 2. If you're shell number 2, how many electrons should be there? 8. If you're shell number 3, how many electrons should be there? 8. So we call that the 288. In order for an electron to go to shell number 2, there has to be at least 2 electrons in the first shell. If you need to go to shell number 3, you have to have more than 10 electrons. 2 in the first shell, 8 in the second shell. Electrons. So only if you're atom number 11 on the periodic table do you occupy the third level. So the rule is 288. There's a couple of exceptions to this rule. We're not going to learn that. You'll learn that in chemistry. In this class, if I show you the first shell and the atom has 3 electrons, which would be lithium, how many electrons go in the first shell? How many go in the second? If you're lithium. I'll show you lithium again. Lithium, atomic number is 3. What does that tell you? There, raise your hand. If you know the atomic number is 3, what do you know? There's 3 protons. And protons equal, so how many electrons? 3. So if you are going to draw lithium's electron configuration, you're going to draw the nucleus. You're going to put the word lithium. Then the first ring is going to have how many electrons? 2, because that's a rule. How many electrons are going to go in the second ring? If you're lithium, raise your hand. I want to hear it. 1. 2 in the first ring, 1 in the second, because it only has 3. Now, if you are, we're going to move on. If you are beryllium, what can you tell me about beryllium? What's its atomic number? Raise your hand. 4. If I know the atomic number, I know what else is 4. Protons. And protons always equal? So how many electrons are there? 4. So we're going to draw, what is it? Beryllium's electron configuration. I'm going to draw the nucleus, which has 4 protons and 4 neutrons. Then I'm going to draw the first ring. How many electrons go in the first ring? 2. How many are left over? So 2 go in the second ring. Now what that tells you is, because the rings should be 2, 8, 8, if an atom only has 2 electrons in the second ring, it's not happy. It needs 6 to be complete. It's missing its full ring. This is why atoms are always combining, okay? So here is sample number 1. Try it, and then we're going to go over the answers together. Sodium. We knew that because we went to the periodic table, we looked for Na, and it says underneath it sodium, okay? How many protons does sodium have? Okay, then, so this is how the test is going to be. I can ask you, how many protons does sodium have? And then I can ask you, how do you know? Right? Who can answer that? That's not how you know, though. Because if you look at the atomic number, which is the top number on a periodic table, because I'm going to give you a periodic table where the atomic number is always on top. It could be on the bottom, I won't lie. You have to know that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, they're in order, okay? But the atomic number equals the number of protons. So that would be how you would answer that question. I know this because I was given the atomic number, which is the number at the top of the periodic table, and the atomic number equals the number of protons. Neutrons. Okay. How do you know if I asked you that? There's an answer to this test question. How do you know? Yes. Correct. You subtract the atomic mass minus protons. Always remember, yes, protons equal the atomic number, but because I just showed you there's exceptions sometimes, you want to stick to the formula. Neutrons equal atomic mass minus protons. Because protons plus neutrons equal atomic mass. Yes. Because that's what it is on the periodic table without rounding. It's 99? Okay. Because I made a typo. Let's fix that right now. You put 12, you're fine. Okay? How many electrons are there? How do you know that? Because protons equal electrons. That's your answer. There, we just answered 3 short answer questions, right? What is the atomic number? How do you know that? Because it was given to you on the periodic table. It's a number on the top. What's the atomic mass? 2299, right? Or is it 99? Yeah. And it's given to you on the periodic table. And how many electrons? This is the first time you see this question, which I asked it to you before. How many electrons is sodium seeking? Raise your hand if you think you might know the answer. Okay. Why do you say 7?
Because I counted all the ones on there. There's 11, and I know 2 plus 8 plus 8 is 18, so I did 18 minus 11 is 7.
Well, that was an interesting version of events. Who has another answer?
I just counted how many electrons are on the outer ring.
And then how many are there?
There's 1, so 8 minus 1 is 7.
Because on the outer ring, there's only 1. And in order for that ring to be complete, it's missing 7. Because it wants to have 8 to be complete. So yes, it's missing 7. What's the name of this element? Chlorine. You're so nice. How many protons does chlorine have? I want to see how many hands are getting it. So when I ask you this question, it's just, if you don't want to answer me, I just want to see if you get it. Can I pick on you? Yes, because I want to hear from different people. How do you know this? Good, because protons equal the atomic number. What else do protons equal? Electrons. So we know that the electrons are 17, right? How do we figure out the neutrons? Subtract the atomic mass from 17, so you don't get a number. So what's the atomic mass? 35.45. Is that one right? Yeah. So what's my number of neutrons? Good. My atomic number, as we stipulated, equals the number of protons. How many electrons is chlorine seeking? Huh? None? How do you know this? All the rings are full. 1, 2, 3, 4, 5, 6, 7. So I see 7. Did I do that right? So how many electrons is it seeking? 1, because it needs 8. Always start. So if it's 17, you're going to draw your first 2, and then you're going to write the number 15. I have 15 left. Then you're going to do the next 8. How many do you have left? 15 minus 8? 7. You draw your next 7, you know there's 1 left. Or you do what Brady did. 2 plus 8 plus 8, and then, right? It worked out. All right. Question.